Water can exist in three possible phases, namely solid, liquid, and vapor. Hence, there can be three forms in equilibrium, that is, liquid vapor equilibrium, solid vapor equilibrium, and solid liquid equilibrium. In this figure, the curve OA represents the equilibrium between liquid water and the vapor at different phases. This curve is known as vapor pressure curve. For each vapor pressure, only one temperature can be maintained. The degree of freedom of the system on the curve OA is univariate. Let me take another curve OB, which represents equilibrium between solid and the vapor state. This curve is known as sublimation curve. Each temperature, for each temperature, there can be only one pressure, and similarly, for each pressure, there can be only one temperature. Along curve OA, two phases which exist are liquid and vapor, while along the curve OB, the two phases which exist are solid and vapor. At the point O, where the two curves meet, three phases exist, namely solid, liquid, and the vapor. This point is known as the triple point. The temperature and pressure at the triple point in case of water is 0.0075 degrees centigrade temperature, and the pressure at this point is 4.58 atmospheric pressure. The curve OC represents equilibrium between the solid and the liquid phases. This curve is known as fusion curve of the ice because it indicates the temperature and pressure at which the solid ice can coexist in equilibrium with the liquid phase. Along the line OC, both the phases, that is solid and the liquid, coexist. The line OC is inclined towards the pressure axis, which indicates that the melting point of ice is lowered by decrease of pressure. Since the density of ice is less than that of water, Or, in other words, we can say that increase of pressure must lower and decrease of pressure must raise the freezing point of water. It means that while freezing point of a water at a pressure of 4.58 millimeter is 0.0075 degrees centigrade, while at higher pressure of 760 millimeter or 1 atmospheric pressure, it is reduced to 0 degrees centigrade. Along the curve OC, there are two phases, namely ice and the water. Therefore, according to the phase rule, the system should be univariant along the curve OC, and the degree of freedom should be 1. The curve OC meets the other two curves, that is BO and AO curve, at the point O, that is the triple point. In other words, along the curve OA, water and the vapor state coexist. Along the curve OB, solid ice and the vapor coexist. While along the curve OC, ice and water coexist in equilibrium. At the point O, three phases, namely ice, water, and the water vapor coexist, and therefore the system becomes invariant at the point O. That is, its degree of freedom becomes 0. In other words, the three phases, that is, solid, liquid, and gases, can coexist at equilibrium only at a definite temperature and pressure, represented by the point O, that is the triple point. The areas in this figure represents the single phase. The area in the bounded by the region COA represents the liquid phase, whereas the one bounded by AOB is the vapor phase, whereas the area bounded by COB is the solid phase. This was all about the water system, phase diagram of the water system.